let's do what we can to solve this system by graphing. I'm going to start here. I'm going to label these equations. The top one will be equation 1. The bottom one will be equation 2. And I'm going to use the intercept method. No, I don't think I will. Look what I have here. These variables are on one side and the constant on the other, but the 3 does not go evenly into the 2. So I don't think I'll use that. Instead, I think I'll use the slope-intercept form. So for equation 1, let's take our equation, 3x plus y equals 2, and solve for y. Get it in slope-intercept form. So we'll get y equals negative 3x plus 2. So here's our slope. Now the slope is negative 3, but I'm going to write it negative 3 over 1 because the slope is defined as a fraction. And here is our b. So let's get ourselves a coordinate system here. So we just say it magically appears. Let's make it a little bit bigger. Now I'm going to start by plotting the y-intercept. So the y-intercept is at 2, so I'll put a point at 2 here. And then I'm going to use the slope to get another point. And remember, the slope is the fraction. The bottom number is the horizontal change. The top number is the vertical change. So from this point, I'm going to go to the right one, down 3. That's what it says here, right? To the right one, down 3. So let's do it. I'll put little dots there. To the right one, down 3, there's a point. Now I'm going to do it again because those points are kind of close together. If I can stretch them out a little bit, to the right one, down 3, 1, 2, 3, I can maybe get a little better graph. To the right one, down 3. Okay, maybe that's not going to do it. That is the wrong point. Let me undo that. To the right one, down 1, 2, 3. There we go. Now, use a straight edge to get a line through those points. Looks pretty good. There's line 1. Now let's get line 2, all right? So in line 2, again, I notice that the 3 goes into the 6 evenly, but the 9 doesn't. So let's solve for y. So here's the second line. 9x plus 3y is 6. And again, if I solve for y, I'll get 3y equals negative 9x plus 6 divided by 3. We'll get y equals, now negative 9 divided by 3 is negative 3x, and then 6 divided by 3 is plus 2. But look at this now, look at this. This equation here is identical to this equation here. So when I graph this second equation, right, when I graph this one here, I'm going to get exactly the same line. So not only is this line 1, but it's also line 2. So in this case, we have infinitely many solutions. So I'm going to write the solutions like that. Since these are coincident lines, right, that's what's happening here. These are coincident lines, and I'm going to say no unique solution. Now, can you tell that from looking at this? Look at this first equation. Then compare it to the second equation. Can you get from here to here? Look what you do. You triple, triple, and triple. So this equation here is not really any different than this one. It just looks different, but it's really the same. You just triple, triple, triple. No solution. No unique solution. So this problem has no unique solution, but let's mention something. Now, I notice that the slopes are the same, right? The slopes are the same, negative 3 and negative 3. And not only that, but the y-intercepts are the same. So not only are the slopes the same, which means that both lines have the same steepness, but they intercept the y-axis at the same place. So I know that they're not only parallel, not only the same line, but I don't have something going on like this. I don't have this. They're more than parallel. They actually coincide. And then because they actually coincide, I know that I have no unique solution. Now, if these numbers were different, this was 2 and this was like 5 or something, then these lines would be parallel and there would be no solution.